Nazi Germany first launched the V-2 in 1942. At 46 feet, it was as tall as a 4-story building, and by the end of World War II, it would be carrying bombs across the English Channel to London. But many lessons had to be learned before it could rain down its deadly payload onto unsuspecting English citizens. During its genesis, the V-2 suffered seemingly every imaginable type of malfunction.
Were every reason under the sun. One typical problem was the engine would start and then it would cut off. Very often just above the launch pad. Guidance problems were typical. Guidance problems included everything. Jet vanes that didn't work, electronic failures, you name it. I think it just shows you how fragile and new this technology was.
The V-2 was blowing itself all over the landscape because it was new. I mean, every nut and bolt in that thing was not only invented from scratch, but under the intense pressure from the Nazi government to get this thing built and flying right now.
Despite its early problems, the V-2 ultimately would serve as a revolutionary prototype for the modern rocket designs that followed. The Nazi engineers who designed the V-2, including their leader, Werner von Braun, would eventually emigrate to the United States after the war. What they learned from the V-2 failures would play a crucial role in rocket engineering's most dramatic achievement just 20
Another V-2 rocket is prepared for launching by the Army Air Forces at White Sands Proving Ground in New Mexico. A world's altitude record of 104 miles has been established here, and the U.S. is fast catching up in rocket warfare. Something's wrong. The rocket is dropping down off course. A rocket boomerang.
Back failures of Titan 34Ds in 1985 and 1986 might have accelerated Titan's demise. But instead, a more catastrophic disaster brought the space program to an immediate halt.
what you're seeing is incredible footage of the first stage of the SpaceX Falcon 9 rocket almost landing on what the company calls an autonomous spaceport drone ship in the middle of the Atlantic. As you can see, it didn't exactly go as planned. The rocket hits the barge at about a 45-degree angle and basically explodes upon impact. Now, the company said this happened basically because there wasn't enough hydraulic fluid on board to control the grid fins. Now, the grid fins are basically what steer the rocket towards its target. And apparently, it ran out of fluid just a minute before landing. The good news is the rocket hit its target, and the company has already added 50% more hydraulic fluid for their next mission. So why are they doing this? The company's CEO, Elon Musk, is dead set on making reusable rockets because that would dramatically reduce the cost of space exploration. Right now, rockets are only used once and they're incredibly expensive. While this first attempt was not successful, SpaceX says there are at least a dozen missions in the next year where they're going to test the system and hopefully land the rocket safely on the barge.
Ебать его! $200 million of spacecraft and satellites gone in seconds. This incredible crash of an unmanned Proton-M rocket was caught on camera at the Baikonur Cosmodrome in Kazakhstan. The spacecraft failed almost immediately after lifting off with 3 communications satellites on board. Fortunately, no one was killed in the incident and there were no reported injuries. But local residents were prepared for evacuation in case there were any toxic emissions from the burning rocket fuel. An investigation has been launched into the crash, which it's currently believed was likely caused by a faulty engine or guidance computer.
Indian space research authorities say there's no flaw with the design of its space rocket that exploded on takeoff. The $38 million rocket took off from the southern state of Andhra Pradesh on Christmas Day. It was carrying the country's heaviest communications satellite, weighing in at over 2,000 kilograms. But 50 seconds later, live television footage showed the rocket disappearing in a plume of smoke. Experts say there was a communication problem between the rocket's onboard computer that caused the rocket to veer off its flight path and crack up under its heavy load. Authorities will be launching another satellite in February using a different and proven launch rocket.
We definitely feel disappointed, but then we also know this is not a design issue. This is something like an accident. So we have to find out what caused the snapping of the connector, and we have to correct it. But there is no problem with any of the systems of the vehicle.
So we have to do the integration of the satellite with the launch vehicle, go through the checks to be done at the vehicle level with the satellites. And our expectation is by February 1st week, we should be able to have the launch.